I hope you guys are doing your absolute best. School is going great. And let's start today's lesson. So, today, what we're going to be doing is a very important topic that's not just going to influence your grade 9 year, but also going to influence your grade 10, 11, and 12. And even after in like college, it's going to carry on because today we're going to be learning about integers. And I'm sorry about my handwriting, but you guys have to bear with it. So, today we're going to be learning about what integers mean, how to add them, subtract them, multiply them, divide them. And then we'll also be doing infinity, density, and limits. And I'm sorry for my handwriting. I'll make it better. But let's begin with integers. That's as it's like a different topic than the other one. So let's begin with integers. So when we think of an integer, what comes to your mind? I'll give you a second to think. Okay. So like an integer, let's make a number line first. So an integer, let's say this is a number line. It's a straight line, okay? So 0 is our middle. This is the origin point. Like every number line has 0 in the middle if you're going to both positive and negative numbers. So on the left hand side, it's all negative numbers. Left side, right? Left of 0. And right side is positive numbers. That's why these arrows that we see that I put on the end here represent positive infinity on the right side and negative infinity on the left side. So let's say I have to put positive 2 on this number line. Where would that be? 2 steps to the right, right? So here it's going to be positive 1, and on the second one it's going to be positive 2. And let's do the same. Let's say I have to find negative 1 on this number line. It's just going to be one step to the left. Here is negative 1. And this basically shows us what integers are. Integers are basically any whole number from like that stretches from like negative infinity to positive infinity, but it does not include decimals like negative 1.1. This is not an integer. It does not include any fractions like 5 over 4, like negative 5 over 4 is also not an integer. So it's basically like every number that goes like negative 5, negative 4, negative 3, like jump by a +1. Okay, so let's introduce you to the concept of adding and subtracting integers. So adding and subtracting integers is the same as adding any whole numbers. It's just how they're phrased. Like, for example, let's do a question. Let's say the question is negative 2 plus 6. And when you're going to look at it, you'll be like, I have never learned how to put a negative number in front of a positive 6. But isn't saying negative 2 plus 6 the same thing as saying 6 minus 2? And both of them actually gives 4, right? So the same answer. Now let's do another one, which is negative 1 minus 5, right? And let's look at this one through number lines. So this is our 0. We're going to be moving 1 left to negative 1 and moving 5 more left. So our end result is going to be negative 1 minus 5, which is negative 6. So negative 6 is here. So I'll give you a tip. So when it's let's move on. Like a tip that I was gonna give you was just this: if it's like a -1 getting subtracted by another number, they're just gonna add to themselves. When it's a -5 and a +2, they're just gonna, it's the same thing as saying 2 minus 5, which equals -3. Right? Just don't overthink it. In addition and subtraction, the best method is to not overthink it and just just use what you have learned over the like grade 6, 7, and 8. 6, 7, I know I'm catching up with this new generation, right? Okay, now let's move on to multiplying, right? Multiplying. This is where it starts to get a bit weird, but I'll break it down for you in detail. So how do we multiply integers? So usually when you see multiplication, it's like 4 times 2 or 4 times 2. However you've seen it. This is also a way to show 0 like the dot, right? So all of them give us 8 because 4 times 2 equals 8. Now let's say we have 4 times -2. What would that give us? And yes, it will give us -8. And let's say we have -4 times -2. What would that give us? It would give us +8 because these negatives cancel out. Yeah. And let's say we have -4 and +2 getting multiplied. That will give us -8 as well. So here's a tip. So when it's a negative times a negative, it would lead to a positive. When it's a positive times a positive, it would also give us a positive. These two give us positive. But when it's a negative times a positive, this would give us negative. And when it's a positive times a negative, it would also give us negative. Negative. So this is like, you need to kind of memorize this, and like this is very important. Just like try to remember. But I think you guys have been learning this from like a young age, so I think you should be fine. And yeah, let's do some practice problems with these. So, oh no, division first. So let's do division with integers. So an example of this would be -5 divide, actually no, not -5. Let's do -10 divided by 5. We follow the same rules here as well. So -10 divided by -5 is would give us 2, would give us -2. It's the same as multiplying 5 by -2, which would equals -10, right? So the same rules follow and apply here as well. So let's say I have 10 over 5, that equals 2. Let's say I have 10 over -5, which equals -2, right? It's the same rules, just let's say I have -10 over -5. That would just give me 2 because these cancel out. So it would just be 5 over 2. Okay? Now I'll give you some practice problems to try by yourself, and we'll take them up shortly. And one would be for homework, because homework I think is important for learning, I guess. So the question is 15 plus 5 minus 3 minus 11. So take like, I'll give you like 5 seconds to do this. Okay, so let's understand how to do this. So 15 plus 5, let's start with this. 15 plus 5 gives us what? 1. -3 minus 11. We're adding two whole numbers, remember? So we're adding them, and the sign stays. It's going to be -14. What would that give us? 20 minus 14 gives us 6. And this is our answer. Good. Let's do another one with multiplication. 2 times negative 8 minus 3 minus 2 plus 20 divided by, wait, give me a sec, I'm thinking. Um, hmm, divided by 2. Or I could have done divided by 2, it's the same thing. Divided by 2. Okay? But let's do it the way I did it. So this is gonna have to go. I'm sorry. Let's do divided by negative 2, actually make it harder for you guys. I'll give you like 10 seconds to do this and take your time. Okay, let's take this up. So let's begin with this. The first thing. We have negative 8 times 2, which gives us negative 16 because this is positive times a negative gives us a negative. Then we have negative 3 times negative 2. This gives us positive 6. And then we have a positive 20. And we're dividing the whole thing by a negative 2. You should be able to do this part, let's just say. So now we have, this gives us 10, negative 10 plus 20. So we have negative 10 plus 20 over negative 2, which gives us 10, positive 10, because negative and a positive, and positive is bigger, over negative 2, due to which we get negative 5, right? This is our answer, because it's a negative at the bottom and a positive on top. And a negative and a positive dividing gives us a negative number. Okay? And here, you know what? No homework for you guys today. Let's just do everything in class because it's a big topic and I don't want to be talking a lot. And I think if you guys understand the main concept of this, like everything we've talked about, you guys will do great in everything that's going to come in the future. So now we'll move on to a different topic, like integers is done. Integers was just this much. Okay? It's just easy stuff. It's just about practicing. Like, I know you guys will be good. Ooh, my pen's still working. I know you guys will be good. You guys will be fine with integers. Now, let's move on to a different topic, which is infinity. Let me zoom. Infinity, density, and limits. And when you guys hear the word density, no, I know you'll be like, oh, we're going back to science. No, this is like a different density, and I'm telling you right now, this was like a topic which I don't know, I struggled with, but looking back, I think it was really easy. So let's start with infinity. Let's understand what it means. So what is infinity? Infinity basically means that the number like is unending, like there's no end to it, like it's not a real number. It's like a hypothetical fake number, like I, which is like the square root of -1. You'll learn this in the future. Like it's not a real number. It's like a made up like infinity sign. It's also like I don't know who made it, but it was like a guy who came up like I can't think of all the numbers. Let's just come up with this beautiful sign that we're gonna be using like forever now, right? And like some examples of this could be like lines, because like remember like when we were making number lines, there were like arrows which showed how like they would go on forever. And like some number sets, like real numbers, like they kind of contain like infinite values. Like number sets contain infinite values, right? And like fractions could kind of go on infinitely. Could like look 1/2, 1/4, 1/8, 1/16. Like it's like it's like when there's like no end, like they could just keep on going forever, right? This is what infinity means. I'm going to the left. Means like negative. Okay. Now let's move on to like this is all infinite. Like this is infinite. That's it. Like just a concept. right? Like just as a concept. Now let's move on to density. So let's understand what is density. Density like basically means how crowded something is inside a space. So like let's say it's me and I'm pretty big. And let's say I have a friend who's also very big. Like how much space we have in the between. Because if we're going to compare ourselves to someone who's very tiny, let's just say, like two people, they're of course going to have more space than us, right? More space is the key word here, or less space. I'm sorry for my handwriting again, guys. I can't control it. I'm like too old to change it at this point. So let's see. Let's say we have two number sets. Let's say we have an example of integers between -10 and 10, or rational numbers between 1 and 2. Okay? So, which one do you think is more dense? Let's just say. And remember, I'll make a table for you. Like, this is what I learned. So it begins like these are natural numbers. Then comes whole numbers. Then comes integers. Remember that, right? These are starting from 1. Whole numbers begin from 0. And these begin like negative, then 0, and then positive. So like integers includes whole numbers and natural numbers. And if you want an explanation of rational numbers, so rational numbers are basically like rational numbers are basically numbers that can be written as a fraction of two integers. Like they are basically like they can also be fractions like 3/4, -7/2, right? So they can be decimals. So it can be like 0.33 or like 1.25, 1, make 1.25, right? So now let's go back to the question. Which one do you think is more dense? More dense, dense. And by dense, I mean has more numbers, like more numbers between them. I'll give you like 2 seconds to think. Un, deux. Okay. So I know a lot of you will be thinking like -10 to 10 have like more space or like it's more dense compared to like 1 and 2 like rational numbers. But okay, if you think about the concept of integers as I just told you, it's just going up by ones, right? +1, +1, +1. And -10 to 10 only gives us what? 20, 20 numbers, right? But when we go between like rational numbers between 1 and 2, we have a lot of them because we can go from like, I don't know, like 1/2, 1/16, 0.2, 0.1, 0.99, right? It's like, let's just, yeah, it's just way more, right? So this is like the analogy I just gave you guys. This is like me and my friend here. We are big, big, right? Let's make some smiley faces because we're happy because we're studying math, right? So rational numbers between 1 and 2 are like us. We're big. But integers between -10 and like are small because it's only like whole numbers. And by whole numbers I mean they go up by 1. Don't get me wrong and say that whole numbers are only numbers that like start at 0 and like go up 1. What I mean by whole numbers is like integers basically like start at -1 and then go to 0. Like they don't have decimals between them. Okie dokie, let's move on to the final part of today's lesson, which is limits. And let's understand what it is. So a limit is basically like a value that a sequence or a function approaches, but it never reaches. So let's say an example of this would be as you keep dividing by 2, you get 1, 0.5, like let's say 1, right? And then you get 1 over 2, which is 0.5. Then you get 1 over 4, which is 0.25, right? Then you get like 0.125, 0.1, right? But like you get closer to 0, like with everything you do, like closer, but never reach it. Like you never like never reach it. So our limit is equal to 0. So like we get close to it. Like it's like you want like a 90 on a test but get an 89, right? You get close to it, but like you're still not there, right? You still have to work for it, but I know what you will. It'll be fine. Don't worry about grade 9 marks. They don't matter. And like in 10 years, you're gonna be looking back and be like, why was I trying so hard in grade 9? I should have been going out with my friends, enjoying my life, and doing some more math because I'm your teacher and I know you like me. I don't know about my handwriting though. So let's do like 2 questions. So and then I'll leave you guys because this video has been like 22 minutes already. So let's like order from like least to greatest. So let's say I give you 5 numbers. Let's say root 25, -4. This is a mm, and let's say per. Okay. So these are 4 things that you have to order from least to greatest. I'll give you like 2 seconds to do it. Pause the video and take your time. Okay, let's begin. So root 25. Let's basically simplify all of them first. These 2 are simplified, yes, but these 2 are not. Right? So let's simplify them first. So root 25 is equal to 5, right? We know that? Okay, good. Then we have -4. Then we have -5 times what? Times -10. And we just learned this. This gives us what? A negative times a negative gives us a positive. And 5 times 10 is 50. So this is 50. And then we have 76. So least to greatest, if you want to put it, would be -4 is smaller than 5, which is smaller than 50, and which is smaller than 76. So this is our like ordering from least to greatest. Now, um, that's, I think I had a lesson plan and I'm looking at it right now. And that's mostly it. I just had practice for integers because I thought that was gonna be the most important thing. But I'll give you like one more question on like, I don't know. Let's look at what could be hard here real quick. Sorry. Let's look at mm, let's look at density again. So let's say I have all natural numbers between 1 to 5 and whole numbers from 0 to 5. Which one will be more dense? And yes, you're right, it would be whole numbers because we included 0 here as well. So 0, 1, 2, 3, 4, 5. So this is like technically 6. And then here just would be 1, 2, 3, 4, and 5. So this is technically just 5, right? Okay. Let's see what else I can ask you guys and make your life more miserable. We just did density. Limits. Okay, I think I can explain this a little bit more deeply, I guess. Um, so limits, as I basically explained first, was basically like a number like zero, right? It never reaches. It's like a target value. So it's like a pattern, function, or sequence that like it gets closer and closer to, but never actually gets to, right? And I just explained this here example. And yeah, I think this was everything that we could talk about in today's lesson. And today we did a lot. Damn, why is it so? You know what? I'll go green because I'm happy today. Today we did a lot of stuff. Right? 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 We did like 4 things. So make sure you practice. Practice. Because as we know, practice makes what? Not perfect. Practice helps you get better at stuff. Because if I was perfect, I would be like Muhammad Ali at this point, or who was a good mathematician. I don't know. You tell me in the comments, actually. So today we did integers, right? We did density, limits, and even infinity, like the concept of infinity and what it is, like the science, right? So remember, integers tell us position, density tells us how crowded numbers are, and limits tell us what we're getting closer to but never reaching. Like, I'll give you an example which you're going to be learning like next year for um or like limits, I guess. Like if you're gonna like get this graph like a reciprocal graph, which is like 1/x, it's going to look like this, right? Something like this, and it's asymptotes, which are basically like on like the x and y axis, they're going to be on zero because this graph gets like really like close to zero, but actually never touches it. That's why they're called the asymptotes. Asymptotes. This is a concept you'll be learning in grade 10 IB. And this is like a grade 11 unit if you're in mainstream. In Canada, at least. I don't know about like India and like, I don't know, any other place. And this is like, we're close to like 30 minutes at this point. But great work today. And now, if you want help with specific stuff, there's going to be material posted. And make sure you try out trial questions, find them online, or even the worksheet that's going to be posted with this lesson. And check over the mistakes. And if you need help, I'll be here to help you. And you can always watch the video again. So, guess what? See ya in the next video.